Hi, in this video we'll see an introduction to cloud computing and virtualization. So let's get started. What is cloud computing? There is no standard single unique definition of cloud computing. The definition on cloud computing varies, but if we look into different definitions, they stand on one page about cloud computing, that it uses remote computing resources that is under someone else's ownership and management, which means if I use a computer and computing resources, computer networks, any kind of computing resources that is not under my management or under my ownership, that's somewhere else, I don't manage them, but I just use the resources, then that is called cloud computing. However, as I said, that there is no standard, one standard definition for cloud computing. Broadly speaking, cloud computing means using remote resources, and the ownership, it might be under someone else's ownership, or it might be under your own organization's ownership, as you'll see later on. There are a number of definitions. Some researchers, most of the researchers agree on the definition that you see on the screen now, that as I was discussing, it should be on a remote data center, and ownership, it might be under someone else's ownership and management, or it might be within your own organization's ownership, but it is normally a remote data center where you have computing infrastructure, computer networks, computers, and you use virtualization for resource sharing. In other video tutorials, we'll see what is virtualization and how resource sharing is done. So I'll just leave it here only by saying that virtualization is a very significant contributing technology in cloud computing, and that is why a lot of other researchers include virtualization as part of the definition for cloud computing. So we have a remote data center, we have resource sharing using virtualization, and cloud computing is on-demand service, which means whenever I need it, I should be able to get the service, and whenever I don't need to use it, I should be able to forget it. And the billing is normally pay as you go. I should be paying only for what I used and for the time I use, and it helps you to get rid of monthly use bill. You can use, if you use something for 5 hours in a month, if you use a computer 5 hours in a month, you pay for 5 hours, you don't pay for the whole month. And access via internet, as the data center is remote, so access via internet. So if we generalize, then we can actually say that there's some remote computing resources that is accessed through networking. In this case, we can say internet, and we use it whenever we need it, and we pay only for what we use, and that is what we can say cloud computing. So cloud computing itself is not any technology, it is an approach. If we look at the definition, we see that in the remote data center we can use any computing, and it might be any kind of computing technologies. Cloud computing means remote resources and accessing via internet, and have some on-demand pay-as-you-go sort of things. So technically, in terms of technology, cloud computing itself is rather a computing approach, not a technology itself. So I argue that it is a conceptual approach to computing, and it can encapsulate any form of computing by definition. And since we said virtualization is a significant technology in cloud computing, we definitely need to know about virtualization. So what is virtualization? very roughly speaking, we can say using one physical computer to install more than one operating systems that would run in parallel. It's not dual booting, it's simultaneous booting, we can say. In dual booting, you can install two operating systems and you can run one or the other, but by using virtualization, you can simultaneously run more than one operating system on one physical computer, depending on the capacity configuration of the computer. So how it helps? One of the major help that we get from virtualization is cost minimization. For example, if I can install 5 operating systems in one computer, instead of buying 5 computers, I will buy just one computer, and it will help me to save the expenses for 4 computers. And there is a rough estimation from different resources that virtualization helps organizations to save around 40% of total cost, which is actually the 40% cost minimization is a very big achievement. So to talk about virtualization, if we look into this figure, this image, the moment I took this screenshot, you see that my CPU was being used 25% of it, 35% in memory, 12% of disk. Now you see that the rest of the CPU, memory and disk space, probably not disk space, but let's say memory and CPU, they are being wasted because no one else is using my computer. Now, if I could install another operating system, and if there was a way by which I could let someone else use the wasted 75% of my CPU, let's say, then it would be something good. And that is what virtualization helps us to achieve: cost minimization, resource sharing, and optimal use of resources. So let's have further illustration on virtualization, how we do that. Here you have one illustration of type 1 hypervisor, which is also known as bare metal hypervisor. If you look carefully, this is, please follow my cursor, this is the computer, let's say physical computer, and we installed a piece of software which we are calling hypervisor, and this is actually the virtualization platform. On top of that virtualization platform, we installed, let's say, operating system 1, 2, 3, 4 operating systems on 4 virtual computers. So we are calling this the host computer, and these virtual computers, we are calling them virtual machines or virtual servers. Now, from outside, through internet, from some remote places, if an end user is connecting to, let's say, operating system 3, they wouldn't feel the difference. They wouldn't understand the total scenario. They wouldn't feel a chaos. They'll just feel that they are using one operating system on one computer. And so if, let's say, that 4 different end users are connecting to 4 different virtual machines from remote places, they would feel that they are using their own computer, their own operating system. Whereas, because of using virtualization, they are actually using one computer, and though all those computers, virtual machines and or virtual servers, they are actually residing in one physical computer. And that is how all these 4 virtual machines are sharing the resources of one physical computer, this computer, host computer, and that is how virtualization saves money, reduces cost, and shares resources. For example, all of them, these 4 virtual machines are using the same RAM, random access memory, or primary memory of this physical computer. So here we have seen the piece of software that is the platform is known as hypervisor, and there are 2 different types of hypervisor. Type 1, that's the one we have seen. It becomes the platform on the computer and then holds other virtual machines. And as we discussed, it is also known as bare metal hypervisor. On the other hand, the other type of hypervisor is called type 2 hypervisor. So the difference here is that This hypervisor resides on an operating system. For example, if you have a Linux or Windows operating system, you can install a type 2 hypervisor, and on that hypervisor you can install the virtual machines. In other tutorials we'll see type 2 hypervisor, so where we'll see that on the guest computer we install hypervisor on the operating system installed, and in that hypervisor we install multiple virtual machines. However, type 1 or type 2, the users from outside world, they will not feel any difference, and they will feel that they are exactly the same thing. So this is virtualization, a very significant revolutionary technology for the popularity of cloud computing. So what are the examples of cloud computing? I won't go through any complex examples. You already are using cloud computing. For example, emails. Any email you use. When you use email service, emails, you care about the privacy security of your emails. You want to send and receive emails, and any other related functionalities you want from email communications, but you do not care where those emails are stored, in which computer, and how those computers are being managed. You don't need to store them locally. So you are actually using cloud computing. Your emails are stored elsewhere in some servers you even don't know, and you don't manage those computers. So you're using remote resources. This is cloud computing. There is no magic in cloud computing. It is recently it is becoming popular, but it is not a new concept. And another example might be any online storage. We have a lot of cloud storage, we say. So this is another example of cloud computing. And high performance computing, for example, whatever is the reason, if an organization needs a supercomputer, let's say, for 5 hours a month, and it doesn't make sense for them in terms of money and administration, management, whatever is the reason, it doesn't make sense for the organization to purchase a supercomputer because they need it just for 5 hours a month. So by cloud computing, the clouds, those organizations that provide cloud services, they can have supercomputers, and they can tell people that, hey, we have supercomputers, use it whenever you need it for those 5 hours, and just pay bill only for that 5 hours and then just forget. And that is how cloud computing, those who provide cloud services, cloud computing, can offer pay-as-you-go and on-demand service that we have seen earlier in the definition of cloud computing. So in high-performance computing, some organizations may not afford, or it might not be feasible to buy supercomputers, super-performing computers, but they can hire the computers for the time they will use from cloud service providers. So these are some examples of cloud computing. Now comes the cloud types. These are all conceptual separation. When you say public cloud, you mean that the data center that we referred earlier is under the management and ownership of someone else, and anyone can use that data center. For example, your free email services that you have. Private cloud, okay, the data center is owned by an organization and it is used only by them, not by anyone else. And that is why the private data center is called the private cloud. Community cloud could be a cloud that is provided by a number of organizations, and they use it. Let's say 10 organizations, they came up a consensus, a decision that, okay, we will build a cloud, and that will be a general cloud for all of us to use, so that we can call community cloud. Hybrid cloud, a mixture of any of the above three. You can have some of your service in the public cloud. For example, you might have your data that are not very sensitive in public cloud for your organization, and at the same time the sensitive information, for example your employee details, you might keep it within your data center. That is private cloud. So you are using hybrid cloud, a mix of both. We have 4 cloud types, and also you have service model or cloud deployment models, which are mainly known as infrastructure as a service, platform as a service, and software as a service. So what is infrastructure as a service? When you can use the service providers, cloud service providers infrastructure, their computer networking, that is called infrastructure. So when a service provider, cloud service provider, lets you use their infrastructure, that is called IaaS. On the other hand, you might be given access only to one virtual machine, and you can use only one operating system where you can install software and whatever you want to do on the operating system. If you're given to only that level of access, then it is called platform as a service. On the other hand, you might be given access only to one software, let's say one website or one you become a user of cloud-based software on the web, and you can use only that software. You can't do anything else on that on the server where the software is installed. Then you're using just the software. That's why this is called software as a service. So if you look carefully, SaaS, software as a service, is just the software. Platform as a service means an operating system installed on a virtual machine. On the other hand, just the whole computer, one computer. And IaaS, on the other hand, gives you more degree of freedom, where you have computer, maybe multiple computer networking, and everything that makes an infrastructure for computer networks. And if we look the last part, AAS, it became a generic term where we say XaaS, something that is offered as a service on the cloud is known as XaaS. For example, SICaaS, security as a service, DaaS, database as a service. So X as a service became the generic term for different cloud service models that are offered by cloud service providers. So let's go through some terminologies before we conclude this tutorial. CSP, we discussed, cloud service provider is the one who has the data center, who offers people cloud services. Cloud broker, you might find some organizations or some people who makes the deal between the cloud service provider and the people who uses the cloud services. Cloud auditor, for a number of reasons, a cloud service provider might need to be checked for compliance and for a lot of other aspects. For example, data privacy, and whether the data privacy acts in any region of the world is followed properly by a CSP, how authentic the CSP is. There should be some independent authorities to audit the activities of CSPs, and they are known as cloud auditor. And finally, of course, whoever is using the cloud are called cloud consumers. Might be an individual, might be an organization. So these are some terminologies related to cloud computing. And based on that this introductory understanding on cloud computing and virtualization, we will move forward. Thank you.